Welcome to Homework Lib.
What is the sampling distribution of the mean? Well, the sampling distribution of the mean for samples of size 10 from, well, I guess all of your choices begin with, because the population diameter of 10 espouses is approximately normally distributed, then the sampling distribution of the mean will also be approximately normally distributed. So that is choice C. Now you want to find the probability that the sample mean is less than 2.56. In order to do this to 4 decimal places, we have to understand that the mean of the sampling distribution of the mean, which will denote like mu sub x bar, that's going to be equal to the population mean, which is 2.57. The standard deviation of the sampling distribution of the mean is sigma over the square root of n. So in this case, that's going to be 0.05 over the square root of 10. And that is approximately 0.0158. Now, for the probability, we need a z-score. A z-score for 2.56. So that's going to be 2.56 minus the mean 2.57 over the standard deviation. I'm going to do it exactly though, because we want this z-score to be pretty as accurate as we can. And so 2.56 minus 2.57 is negative 0.01. When you divide it by that standard deviation, you get negative 0.63246. And we want a z, you could probably use negative 0.63 from the table, but we want the probability. So the probability that the sample mean is less than 2.56 is the same as the probability that z is less than negative 0.63246. And you can use a calculator or the standard normal table, whatever you usually do, but we want this to 4 places. And that comes out to 0.2635. For part C, the probability that the sample mean is between 2.55 and 2.58. We need z-scores for both of those values. For 2.55, it's negative 1.2649. And for 2.58, that is 0.6325. And again, with a calculator or a standard normal table, that is 0.6335 in 4 places. And for part D, to find the probability that the sample mean will be between 2 values symmetrically distributed around the population mean of 2.57 and covering 52%, we can find the z-scores for the lower and upper bounds of this probability. Since the total probability is 52%, we have 26% on each tail. So we need to find the z-score that corresponds to the 26th percentile and the z-score that corresponds to the 74th percentile. Using a standard normal distribution table or calculator, the lower is negative the lower z-score is negative 0.6264 and the upper is positive 0.6264. And now we can find the values symmetrically distributed around that population mean. If the z-score is typically x minus mu over sigma, then we've got z times sigma plus mu equals x. And so that would be, for the lower, negative 0.6264 times sigma, which is 0.0158, plus the mean of 2.57. And that calculates to you want this to just 2 decimal places would be 2.56. And the upper bound is going to be positive 0.6264 times 0.0158 plus 2.57, which is 2.58.